Greetings, I got a sore-assed dinosaur here. No, the Astro 30 here, and welcome back to AL. Now, if you're new to this channel, please consider going down below and subscribing if you like my content. That will help me out a lot. Thanks. Today we're going to look at finalising the assembly of this bridge-tied load amplifier, or the correct term actually is balanced transformerless. But bridge-tied load has actually gained popularity with this type of thing. But the simplest way to say it is bridged amplifier, whichever. So I'm going to continue on the assembly with the power amplifiers now, and I'm not going to take much footage of this because, well, it's not really necessary. I'll just take little bits along the way. So I'm going to assemble both modules at the same time, or both channels at the same time, because there's no point just building one, then testing it, and then having to go build the last one and test it. Might as well do it all in one go. I'm going to use a DC power supply which has current limiting on it to do the tests. This may not work under plus minus 22 volts DC. My supply only goes up to plus 19, minus 19, so yeah, I may have to put it on the 30 plus 30 DC power supply. As I said in the previous video, although I can't pump this up too high in output to do a power measurement because the supply just will not handle it. So yeah, I won't be able to do a power measurement in this video until I've actually got the correct transformer to plug into it, and then I can do the power measurement. So yeah, unfortunately that's just the way it is. But anyway, I can test these separately though by only just plugging the fuses into the one channel I'm interested in testing and leave the other one open. So rather than talk about it, I'm going to start populating some components here. Might help if I turn my soldering iron on too. And then when I've got some progress, we'll come back, have a look at what we're doing next, and etc. So, strap yourselves in, let's get busy. Son of a bitch! Ran out of solder. Lucky I have a new one. I've got the lower profile resistors installed now. I'm going to install the OR47s, 5 watt devices, after everything else is assembled, because there's a diode that goes under the two sets here. I haven't put the diodes in yet, I'll do that next, but what I want to turn my attention to first, before I do that, is I want to check what these pots, trim pots, are set to. I'll just move this out the way a bit. And I want to measure its resistance to make sure that it's not like 2K, they're 2K pots. It's not 2K one end and 0 the other, because the board does say it has to be set initially to 500 ohm. However, you don't have to set it to 500 ohm. As long as it's set to around halfway, that should be fine. And when you buy these pots, normally they are already set at around about halfway. So I'll just measure across two terminals of this pot. We have about 900, 700 odd ohm there, 800 ohm. That's fine. So there should be like about 1.1 or something there. Yeah, 1.2, that's fine. And this one is set to about 1K. And it should be a little over a K. This side, yes it is, 1.1. Those are perfectly fine. They're set around about halfway. So nothing disastrous is going to happen, because if it's 0 ohms, you're going to be bringing the collector of the long tail pair transistor, the first one, to ground, or to the negative. And the base of the VAS transistor, the BD139, is connected to that point. So you're basically going to be bringing the base of the transistor to the negative rail, which will not make either two transistors very happy. So that's why there is a warning there. So I'll go about installing these as the next step, and then I'll move on to, you know, the diodes, capacitors, and then finally the semiconductors like the transistors. And we'll come back when I'm finished. About half an hour later, most of the components are populated, apart from the output stage, which I've now got to go and find the transistors for that, because I've got them like 6 months ago and they just got put in a tray somewhere. So I've got all the other transistors on there, resistors. These were installed last, just now. So I'm almost up to the testing stage once I get the isolators installed and the transistors, output transistors installed. Now take note with these 5-watt devices, they are proud of the board. I don't know if you can see it. There's like about a 4 or 5 millimeter gap there, which is what you want. However, in my design, I've noticed that these two resistors are very close to these 22 microfarad capacitors. So I don't know, under normal operation there wouldn't be much heat coming off of these resistors, but over time it may dry that capacitor out and that one. But that is part of, I think that's either the bootstrap capacitor, I can't remember the circuit offhand, or it's part of the, across the biasing somewhere. I think it's bootstrap though. Anyway, so I'm going to find my transistors and painstakingly install them and bend them at the right angles, etc. and undo all these 4 screws that I put in previously to mount the transistors, and then we'll come back when we're ready to test it. Now I haven't installed the inductors and resistor combinations, so measuring at test point 2 and test point 4 to adjust the DC offset is not going to work. So I have to take it off of either of these 2 resistors here and here to do the adjustment. So what we can do now is we can start twiddling some potentiometers. No, don't do that. So I'll get ahead now, find these transistors, mount them in. I'll also take note with the BD139 and 140, this is the front of the PCB. All the metal tabs of each device face towards you, and the actual writing side, the printed side, faces towards the heatsink bracket. So don't install them backwards. If I have released this PCB, by the way. I'm going to eventually. The bill of material is going to be a pain in the ass to do. But only if there's enough interest in it. However, I'm not going to get too ahead of myself here. I'm going to get the transistors installed, and then we'll come back once I do that. Alright, let's get finding stuff. Oh my ass. Alright, there's something really satisfying about having the output stage transistors installed now. They're not soldered in yet. What I want to do is just check that these transistors are isolated from the heatsink bracket, so we don't have a direct short anywhere. So across these 2 screws, well, you'd think you would see continuity, but apparently not. It's probably because they're not actually touching the metalwork, so that's fine. So collector 2, this is continuous, isolated, 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 isolated. Excellent, so the transistors are isolated from the heatsink bracket. So I can now, there's just enough lead length poking through each, I can now go down the line and solder them in. And then we can proceed with testing this out and see how well it works. As I say, I don't think it's going to work on my bench supply because it's not powerful enough. I think the minimum voltage that this will run at is plus minus 22 volts. I think that's what Rod Elliott said on his site when he said he doesn't recommend this be built. I think it's mainly because of the transistors, types of transistors used. He can't guarantee reliability. So if you build it on your own head, be it, I don't even have to trim any of these leads. They're just the perfect length. Okay, so there we go. Those are now soldered in. That one didn't quite go, and now it has. So yeah, just do a double check, make sure the correct part's in the correct place. These are actually from Morocco. Yeah, Morocco. Pity I can't get two transistors the same case. Where I bought these on eBay, I can't remember the seller's name offhand. IC Outpost, I think it is. The picture shows one of these type of cases, which is a TO218, I think, instead of this one. And so the picture is a lie, but I was hoping when I get it they're both the same. No, they're not. Alright, so to start testing I need to first pop in two fuses, 3 amp jobbies. I'm going to start with this channel. And then we're going to hook up the meter to the output point, which is here. And I'll just use some clip leads because my other clip leads that go to the multimeter are being used for the power supply, so that doesn't make it very helpful. So I need to find which, that should be that side. So this is the power. So I'm going to hook it up the same way as I did in the last video, positive over here of one supply and the negative of the other supply over here. So this is the ground point of the circuit, which is the negative of that supply. And I have to unhook all this crap that's tangled up in to get the other supply leads that I need, which is here. And the positive goes to the ground. Might move that down a bit. There we go. Positive goes to ground, and try and avoid shorting things. Negative goes there. Okay, so let me get a set of clip leads for the multimeter and we'll do a quick test. Okie dokie, I've got the positive leads connected to there and the negative lead connected to ground. There's a ground connection here. Circuit's currently off. So I'll turn the circuit on. Now this is either going to work or turn into a voltage to smoke converter. And we actually have bugger all DC offset, which is nice. And currently drawing about 100 mA, but that's including everything. So I'll see if this voltage, yes it does. So we actually should have a working amplifier channel. Look at that, 0 volts. If I touch test point 1, you see how it's jumping around now? That channel is working. Really shouldn't have this just connected like this without a heatsink connected. But for doing a small quick DC test, it's fine. And I'm just going to pop the fuses in. Now this is going to have some voltage on it. That was a fail. I'm surprised there's no sparks. Probably the filter caps are already discharged. So plug that fuse in. So there was no smoke yet, which is good. And I didn't have to do much adjusting. So it looked around about the 1K mark was about right. So leave the ground connected, and I'll now connect to this one, power it on, 90 odd millivolts. So I'll just back that off, which I can, slip with the screwdriver. That's the beauty of using a multi-turn pot. This one's 25 turns. You can actually dial that in really, really nice. See, 0 volts. Now if I touch test point 3, it jumps around, so we know it's working as an amplifier. And if it's in bridge configuration, we would test across, both channels. like that, and we should have 0 volt DC, which we do. So excellent. Those power amplifiers appear, at least appear to my naked eye, to be working. So what I need to do is I need to bolt this, well not bolt it, but clip it to a heatsink so I can then do the next test, which is put it on the oscilloscope and a load and see how it performs. I am extremely happy with how that turned out, and it worked first time, which is always a bonus. So this would be the time now that you would decide whether I go for a bridge configuration or whether I go for a stereo configuration. It's because this section hasn't been built yet. So the right hand channel will be taken off of the negative speaker terminal here and the left off the positive. And you can install J2 down here, the 3-pin header, and not J1 or any of these other components. If you want stereo. If you want bridged, well, you don't install J2, you install J1 and all the other components. So, and be warned, do not ground this amplifier. So do not connect this speaker to ground. You could do it, but it's not advisable. And you can definitely not short the output terminals to either ground or to themselves, because you will definitely destroy the output stage. So yeah, I'm actually quite surprised that worked on plus minus 18 volt thereabouts. Excellent. Alright, so as I say, let me clean up a bit and I'll find out what I've done with a heatsink that I can connect it to, just to do the next bit of testing, which is to see if we've got an audio signal and that it's clean and it's not distorted or, you know, stupid shit like that. Got it set up there. It's G-clamped to the heatsink. It is currently turned on, and you'll be pleased to know that we do have an output signal. So I'm just going to wind the DDS up. Look at that, nice and clean, and it distorts there. We're only on the, we've dropped down to 16 odd volt now, plus minus. We're in times 10 mode, so that is 8.86 volts RMS. So it's not going to be very powerful on this supply because it's not running at the correct what is it, power voltage. So I know that that channel is working. I'll just verify that it will run on 4 ohms by moving my probe around. Yes, it does. It's perfectly stable on 4 ohms, no issues. Excellent. Okay, so now we need to do the test on the second channel. So all I'll do is I'll turn, we've got current limiting going on one side there, so I'll back that off. And we're drawing about 500 mA at the moment, so turn that off. And now I just need to move that test point lead to there to test that channel. I need to put it back to 8 ohms on the dummy load, so I'll do that now. I just need to move this to test point 3 so I can inject the signal into that power amplifier. I'll turn the supply back on. And look at that, we have an output. Isn't that special? And look at it, it's beautiful. And pushing about the same amount of output. Actually, this one appears to be pushing a little bit more. But that's okay. So I'll now move my probe to the 4 ohm side and test that. Yep, we got a signal, it's stable. Excellent. Alright, so that concludes the testing on the power amplifiers, and that's getting slightly warm. And the bracket's getting slightly warm, so I can kill the power supply now. Limiting's gone back on the other channel. Okay. I can turn that off now. So I didn't even need to put it on the higher power supply, it seems to work fine. So I'm happy. So all the low voltage tests are proven to work okay. So the next step is to disconnect all my test leads, is to finalize the assembly by building the bridging adapter, which is here, as I've previously mentioned, and that'll complete the assembly and of course do the two inductors resistor combination. So yeah, perfect. I am extremely happy that it functioned first time out of the box and there's no issues. Unlike several other PCBs I've built in the past that for some reason just do not work right first time. So that'll be the next step, is to build the bridging adapter so we can actually test this in bridge mode. But however, it's getting late in the day, I need to start getting ready for work. I might do that as tomorrow's little job. But it'll be in this video and I'll complete this video. So I'm going to put all this stuff away for now and then we'll move on to the bridging adapter tomorrow. Meat and 2 veg. Well, it's the next day and I'm ready to assemble the bridging adapter here on this side of the amplifier and test that. Now, it may be too low of a voltage for this shunt regulator to work correctly. I am going to test this at the full 30 plus minus voltage from the other power supply, just to make sure that it's going to function. I may have to readjust the DC offsets, but that's fine. And yeah, we'll test out whether the adapter works and see if we get a bridge output, that is a normal sine wave coming out of one channel and an inverted sine wave coming out of the other. So I'm going to get busy doing that. It should only take me about 10 minutes to solder all this in, and then I'll come back. And about 10 minutes later, there it is there, all the parts are soldered in. There is something extremely satisfying about seeing a completely populated board, apart from the optional components which aren't needed. I also haven't got the inductors in there yet either. But I'll just pop the NE5532 op-amp IC into the socket. You could use any dual op-amp here, it doesn't really particularly matter. TL072, LM833, anything like that. Actually, that was a bit preemptive. I'm going to take that back out again, because what I want to do first is I want to measure across pins 8 and 4 to see whether or not we've got the required voltage, just in case something's not wired correctly and it blows the IC up. So that was preemptive, but that's alright, I can always pop him back in. So I just measured between pins 8 and 4, we should see roughly 30 volt, thereabouts. Okay, supply is connected. So I've got an LED also hooked up to a header connector now, so we can see visual indication that the power is on. It's just off of another circuit board, and it just happens to be wired the correct way around. So let me just apply power. Yeah, we got 30 odd volt there, and the LED was flashing and is now solid. It's good. We know that we are drawing, we've got the correct voltage there. The resistors and the 2 diodes are sitting proud of the board, just in case they get hot, because a shunt regulator like this can get quite warm and you don't want it scorching the board. Each op-amp half would draw around about 7 mA, so that's 14 in the end. So these Xeno diodes are taking most of the brunt of that, so yeah, they're going to get quite warm. Right, IC is in. I saw on the meters on the front how accurate they are, I don't know, about 200 mA current draw. That's going to include the 44 odd mA for the relay, the 10 mA for the NE5532, and about probably 60 milliamp per channel. I can verify that by popping the fuses out and measuring the voltage drop across a resistor and just seeing what the actual current draw of the amplifiers are. And in actual fact, I might do that so we can get an idea of, you know, what each of these channels is drawing on its own when it's just sitting there idle. And then we'll get to testing the bridging adapter and see if it functions. Now of course I don't know where my safety test resistors are at the moment, so I'll just do it the easy way. Remove one of the fuses and measure across the fuse holder in current mode. And turn the supply on. We're looking at about 80 mA, which is a little bit on the high side maybe. And they're roughly the same, so all well and good. So we know that these two modules are producing, well not producing, but they're drawing 80 mA each at idle. So the quiescent current is 80 mA, and that's 160 mA for both. So yeah, that's what the idle current is, which is okay. I probably should have considered making the bias adjustable so it could be just dropped down a bit, but it is what it is. Right, on to the next test, which is testing what the output is here doing. I made it easier to connect my signal generator to the input socket because I don't want to make up a cable just to test this. I've just soldered a little pigtail on the bottom of the board on the input pin, and I can ground the oscilloscope and the function generator here at the ground point pin. So all well and good. So let me get that set up, and we'll have a look at what the output is doing. I need another probe though, although that might be a bit more difficult. No, it won't. I can actually connect between test point 1 with one probe and test point 3 with the other probe. That's the input to each power amplifier, and that should show what the output of the IC is doing. Alright, let me get that set up. Got everything hooked up there. Oscilloscope probes on test points 3 and 1 respectively. Input signal going into the input connector, and as we can see there, we've got equal output. One is in phase and the other one is 180 degrees out of phase. It looks to me that the yellow trace, which is test point 1, which is the left hand channel, is the one that's at 180 degrees out, or it could be the way the scope's triggering. But we can see that they're inversed with each other, so that's the whole entire point. So it's extremely exciting to see a thing that you spent a long time doing. That bracket is starting to warm up. I need to hook it to a heatsink. That you spent a long time designing and doing just work. It's a great feeling. It really is. So let me just turn this off. I'm bolted to a heatsink now. I want to look at doing two things. I want to test it at 30 plus minus volts. I also want to do the inductors and solder them in, and then finally we'll do an output test into a speaker. So after double checking the DC offsets, of course. So let me get set up for the next thing, which is testing it at plus minus 30 volt. However, before I do that, it might be a good idea to see if we actually have an output signal in bridge configuration. So I've got it attached to the heatsink, even though it's at an angle. I did try to attach it to the output, but then I forgot I haven't got the inductors connected in circuit, so I'm not going to get an output. So I've just tied it off the generation resistors. And as we can see there, we do have an output. So the problem is my power supply is starting to clip or go into limit. So what I'm going to have to do is I'm going to have to go around the outside of the camera, but there's a chair in the way. I want to see what the maximum output is on the current supply. We've dropped down to 16.2 volt at the moment. That's a better shot of the screen anyway. So I'll just adjust my current limiting to halfway so it's not activating so quick. So I'm going to turn my... We can see it's starting to round out at the top and bottom. Now it's clipping, but it's clipping symmetrically, so that's alright. Limit is just barely coming on. So I'll back that off so it's not on, and I'll back the power off. Well, we've got 1.36 volt RMS coming out, which is actually in times 10. We're still in times 1 at the moment, so that's actually 13.6 volt. And my power supply has dropped down to 14 odd volt. and we're drawing 1.5 amps of current. And according to my rough calculation there, it's 22.4 watts. So it is over double what the single channel was producing, which is nice. So we can see that it is going to produce quite a nice output signal, or I should say output swing. So yeah, now the next thing to do would be to verify that this will run on plus minus 30 volt, and just double check my output offsets. I'm going to disconnect the load for this test because I don't want, you know, DC just going through into the load. So let me reconfigure for that and we'll come back. Okay, everything's connected. The 30 volt supply is connected to the positive side's going to the positive side of the bridge rectifier, negative going to where the other AC terminal is, and the ground to the ground point. So hopefully nothing goes off with a bang. Got the multimeter hooked up to the left hand channel's output and ground, and we'll just have a look. Well, according to this, there is no DC offset. So even at 30 volts it seems to be functioning quite fine. That's cool. So I'll just see if I've got adjustment here. I won't either because I'm in the wrong bloody pin. That's better. Oh, we actually have bugger all DC offsets, so that's alright. So we can connect that, we can adjust that out, preferably the correct way. It means that these resistors need to be turned down a little bit further, which is okay, I guess. Hopefully I didn't kill that amplifier. No, I haven't killed it. Second one is there. Yeah, so there's a little bit of difference between the low power side power supply and the higher power supply. Not much, but we can still adjust it out. So that's the whole entire point of that, and that should be working as an amplifier. It is, but that's on the inverted side, so I can feel that those transistors are getting quite warm just sitting idle. So yes, it's be mindful that when testing a power amplifier like this, that it does really need to be connected to a heatsink, because otherwise you can blow stuff up. So we've got to let the output stage warm up as it is now, and just double check the DC offset as we go periodically to see how that's now changed. I only need like a couple of minutes, and then we can like zero that out completely. So far it's passing all the tests. I mean, a variance of like, you know, 8 to 10 millivolts, either minus or positive, is not really going to hurt anything at the end of the day. Now across both outputs we've got no DC voltage, but it is functioning like an amplifier. So it's passed all those tests. So the next thing to do would be to connect the meat and tube edge, the inductors, wind them and solder them in the board, and then we can go for a final output test into a speaker. And I'm probably going to use the plus minus 30 volt supply for this. So to wind each inductor, we wind on 0.4 millimeter diameter enamel copper wire around a 10 ohm 1 watt resistor body, 11 turns, and that gives us roughly 0.7 microhenry. So I'll first start by scraping the enamel off of one end of this wire. Sandpaper works great for this too. You just need to scrape off enough of the coating in order able to you know, get solder to stick to it, or it just won't stick. So I'm going to wind it as best as I can around the edge of the resistor. So that's sort of what I was going for. It may be a bit messy, but it is what it is. So now I can solder that to the edge of the resistor, or the leg of the resistor, until it looks soldered. And sometimes if you apply enough heat to the enamel copper wire, it will get rid of the insulation. So I'll let that cool for a second, and I'm going to start winding. It doesn't matter which direction you wind the inductor, as long as both are wound in the same direction. It's just, you know, visually more appealing. So right, we start here. That is 1 full turn. 6, 7, 8. Make sure they're all spaced together good, like up against each other. 9, 10, and finally, if you can get it on there, 11. And that's where we exit, at basically where we started. So now I need to, well, first cut that down to length. Which is going to be about that much. And I will need to scrape off the remaining enamel. So I might put both jaws on the component, stop it twisting around on me. Just watch your fingers when using knives, please. I don't want any reports in the comments, instructions unclear, cut my finger off. Now that I've said that, someone's going to be a smart ass and comment that. Alright, so now we can then proceed to pull this off to the side of the resistor so I can solder it to the leg. It's very fiddly. I should have made this a little bit longer, but it's making contact with the resistor leg, so that's fine. Now I can tin that one on. I mean, yes, it's ugly, but it's effective. There we go there. And when you're finished, you should have something that looks like that. Isn't that neat? So there we've got our first inductor. Yeah, it's messy, but it will still work. And I've already pre-bent them, as you can see, at right angles to fit the board, so it makes it a lot easier holding it too. Alright, so let me prep the second inductor, and then I can solder them in the board. Alright, these can be installed in the board now. I did put a dot on the end of the resistor here, which end was the start of the band, so I get them the same way around. It's just my OCD. Actually, I've got a little bit of it extra present there I don't need. Let's cut that little excess bit of enamel copper wire off. As I said, this is ugly but effective. Getting to test point 4 now might prove more challenging. So it looks good enough to me. And you can still get to test point 4. So I can now solder that one in. I just want to not put so much heat up the leads to solder it, because I don't want the enamel copper wire coming unsoldered. So just enough to solder it to the board. And cut off the excess. That's one inductor. Just double checking. Everything looks fine there, nothing's come undone. I will do a resistance test in a minute just to make sure that we've got continuity through there. And it's a roughly 0 ohms. Actually, doing it this way with the heatsink bracket and everything already connected isn't that difficult to do. It may look awkward, but it's doable. And I managed to assemble all of this with all these components in the way, so it's perfectly fine. So this will complete the protector circuit, and it will now be monitoring each output channel for DC and hopefully protect our speaker load when there's a fault. So with those combinations in, what I want to do is I want to get a meter and loose everything on the fucking floor because everything's tangled up with each other. Is I want to do a resistance test and see across each inductor here what we've got. We should have close to 0 ohms, which we'd do if the meter would catch up and then I'd stop losing connection. Lost connection, I'll do it right at the solder joints. There we go, about 0.1 odd ohm or something. So that's alright. This one, lost connection, close to 0 ohms. So yeah, that's good. They're working as an inductor, not a resistor, which is the whole entire point. So now I've got to pick all the stuff that just fell on the floor. My desk is a mess again, for whatever reason, because I just lazy and don't tidy up. So now the next thing to do would be to hook it back up to the heatsink and connect it to a speaker and see if we actually get sound output, clean sound output, or it was a complete waste of time. So I'll get that set back up and I will hook up the power supply again, etc., and we'll then test to see if we have an output at this connector. I already have the plug end already made, so I can connect that directly to the circuit board, and yeah, we'll just go from there. So when testing power amplifiers for the first time into a speaker, I always use a test speaker so I'm not going to damage anything that's worth something. I'm going to take my phone out of my jacket pocket because it's adding as a weight. So I'll turn the power supply on. Okay. I don't have any power for whatever reason. Let me just disconnect the load for a second. Well, that didn't work out so great. The power supply died for whatever reason. So I don't know what happened there, but that power supply is no longer functioning. It must have blown a fuse. Maybe the transformer's dead in it. I don't know, that'll be something I'll have to pull out and look at later. So I'm back on the other DC power supply at a low voltage. Okay, fine. I haven't connected the speaker up yet. That might help. So I'll now plug that in. No issue. Hardly any noise coming out of it. Well, it works. Okay, well that other power supply will have to be checked. But yeah, we did manage to get a test on the other power supply before it died that it doesn't seem to make too much difference with the DC offset that much. So I know it's safe to hook up to a proper transformer now. What I will do is hook it up to a music source, which is going to be fun because I've got no attenuation at the input. But yeah, I'll work that out in a second. I'm just going to find out what I do with my lead. So what I'm going to do is I'm going to leave that running idle for a few minutes, just to see, with the speaker connected, just to see if there's any problems. There shouldn't be. But I really am surprised that that power supply just stopped working. It's really weird. It started to power the circuit and then all of a sudden it just died. It wasn't like it was drawing excessive amounts of current. It shouldn't have been. It may have been, I don't know, but maybe that transformer is so old, because it came out of an old Technics unit, that it's just gone open on the primary. Who knows? I'll investigate that and maybe make a video about that later. Anyway, I'm going to leave this run for a couple more minutes, go off and have a cigarette, and then I'll hook this up to an audio source and play some music through the speaker and, well, just see how it sounds. But so far it seems to work quite happily on the plus minus 17 odd volt that's being supplied to it. So it's doing a heat test on transistors. They don't appear to be getting that overly warm, so the drivers do not need to be heat sinked. Great. Okay, so I'm ready for the final test. It ran fine for 5 minutes unattended. Great, excellent. Now it's time for the all important sound test. So I've got a track ready. Sounds alright. Okay, that's enough of that. We know it works, it sounds alright. The output stage isn't getting all that hot, so that's good. As I say, I don't know what happened to that power supply. It just must have blown a fuse, or the transformer's dead now. It shouldn't be, because we're only drawing 210, well, 270 MA maximum off the power supply. That's with everything at idle, so it should not have blown a fuse on the power supply, but anyway. So that's useless now. But I'll look at that another day. Right now, I'm happy with how this turned out. It's performing excellent, and even only on 17 plus minus volts, which is even more impressive, because I didn't think this power amplifier setup would actually function on such a low voltage, and all the shunt regulators and everything in here would still function at that low voltage. But yeah, as we can see, it does. So next step for this is I'm going to order the correct transformer, hook it up to the header, put the header in, and I will do that test with the transformer on a dim bulb, just to make sure that whatever killed that power supply over there isn't an inherent fault or something when it's running at close to the full voltage. And then I'll do another DC offset adjustment and etc. And then we'll test it again and we'll test what its actual power output is. Unfortunately, the transformer I need, which is a 300 VA 25025, is $160, $159.95 I think it is from Ultronics. It's quite expensive. Toroidal transformers now are fairly expensive, so it would not want to destroy it. So that's why I've got to put it through a dim bulb first, just to make sure that it's not drawing excessive amounts of current. It shouldn't, because it's not doing it on the bench supply, even though it's not an AC source. Yeah, I don't know what happened to the other supply, but that's irrelevant for this meat and 2-veg. So I'm going to... someone left that in a comment on another video of mine, and I found that phrase hilarious. Thanks for that, guy. That was great. Anyway, I'm going to leave this video here. If you enjoyed it, please remember to go down below, like, comment and subscribe if you haven't done so already. And if anyone's interested in actually purchasing this PCB, remember it's going to be around about the $95 Australian for 5 pieces, plus shipping. Let me know in the comments and I'll eventually release the bill of materials and project on PCBWay with in-depth instructions. It just takes a lot of my time to write that stuff up. But just let me know. And we will revisit this in the future once I've got a transformer for it. I might actually order that next week. And yeah, we'll just go from there and just make sure that everything is, you know, functioning as it should. Those drivers are nice and cool. So is the bass. So yeah, balanced transformerless or bridge tied load amplifier. Worked perfectly first time. Took me a couple of days to assemble it and test it individually. But that was the whole entire point. I just wanted to make sure everything was functioning and everything's routed correctly, which it is. And so, yeah, I'm going to leave this video here. Anyways, this is Astro3 saying cheers, thanks for watching.